Hello friends, so welcome to the second video of the class 12 physics, and we are starting with the part 1 unit 1, that is electric charge and electric field. So today we are going to learn about the concept of electric charge, right? So as we had discussed in our first video, we would like to understand any topic by a real life example, then would like to understand the concept behind that particular example, and then we'll learn the details about it. So for charge also we will do it we'll go in the same manner, right? So real life examples are many. We often come across a situation in winter when we are wearing slippers and we are sliding, we are sitting on various plastic chairs, and then we are touching a doorknob and then we form a little shock. Or suppose we touch any other object or we touch a person, then also a momentary shock is observed. So that is because of the static electricity. We also have a famous example, we have done it in our schools also, that in dry winter season when our hairs are also dry and we have a plastic comb, we rub frequently and then we put it near to the bits of papers, and then those bits of paper start dancing or they get attracted. So these are the examples of real life examples of static electricity. And the thing is that because of static electricity, certain objects attract or repel the other objects, right? So the question obviously comes that why they are doing so, why there is a force of attraction or why there is a force of repulsion. So the answer is that it is because of the charge. So now what is charge is something which we need to understand. So before we go any further, we need to understand about the fundamental forces. We know that no body is going to move if no external force is there. You can say if no external force is there, a stationary object which is trying to remain stationary and the object which is in motion is going to remain in motion. Or universally, there are four fundamental forces. So the fundamental forces are first, as you already know, is the gravity. And what is the gravitational force? Because of gravity, there is a force of attraction between two bodies of mass m, and this force is given by G into m1 m2 divided by d square, where d is the distance between the two bodies. So inversely proportional to the distance square and directly proportional to the masses of two bodies, and G is the gravitational constant. So it is called weak force. The magnitude of it is not very high. Of course, Earth is able to have a very large force on us because the mass of Earth is very large compared to us. But there are two objects lying in vicinity, they are not able to exert force of attraction on each other because the masses are not that great, right? Anyway, the second fundamental force is called electric force, about which we are going to learn soon. It is called a strong force. Third is called the strong nuclear force. And fourth is called weak nuclear force. Class 11 physics first unit, you have discussed, you have learned all these fundamental forces, but these are the forces only acting in nature. So we are going to introduce the second one, that is called electric force. third one is very strong force between you can say two neutrons. It is acting in a very short distance in a nucleus itself, and the weak nuclear force is observed in a certain materials which are very heavy, radioactive decay and all. So there you have a weak nuclear force. So weak nuclear force is stronger than gravity, but weaker than these number 2 and number 3. So now let's get on with the. We are trying to understand what is charge. We have the example. We have many real life examples where some objects, when they are rubbed, they possess certain power, and because of which they attract the other object. There are certain combinations only. You can't rub any object and you can't attract any other objects also. So there are certain combinations also. What are those combinations? That also we are going to learn slightly later. So the thing is that let's get to the atomic structure. So in the core of an atom there is a nucleus, and this nucleus is having protons and neutrons, and we have electrons which are orbiting around the nucleus, right? So as per the available structure, the force between two electrons, let's say that this electron and this electron, they are kept 1 centimeter apart. So if there is no other force and there is only gravity, the force of attraction between them should be Fg, which is G into m1 into m2 divided by d square. Now what is m1 and m2? It is mass of electrons, and that is 9.1 into 10 raised to minus 31 kgs. Am I correct? Yes. The distance d is given as 1 centimeter, so it's 0.01 meter, and g is a gravitational constant 6.67 into 10 raised to minus 11. It is Newton meter square, kg minus 2. So if I substitute the values, then Fg which I am going to get is in the range of 5.5 into 10 raised to minus 67 Newton. Look at the value, 10 raised to minus 67, very small value, very small value. So two electrons should experience very small force if only gravity was there, because of their weights only. And this force is attractive. Because of gravity, if the force is there, it has to be attraction only. But actual force, the scientists found that F actual between two electrons, first thing, it is repulsive, like charges, that is two electrons, they repel each other, and the force which is there between them is of the range of 2.3 into 10 raised to minus 24 newtons. So if I take ratio of actual to F expected because of gravity only, so it is nothing but 5.5 2.3 into 10 raised to minus 24 divided by 5.5 into 10 raised to minus 67. So this goes in the range of 10 raised to 43. What does it mean? The actual force found, measured, experienced is 10 raised to 43 times Fg, which was expected only because of gravity. So that means it was proved that time that a very strong force which is there between two electrons, and this very strong force is called electric force. And the presence of this electric force is because of the property of the matter known as charge. Right? So now we have introduced, or we have got to the root of the you can say the definition, that charge is the property of the matter by virtue of which there is a very strong force of repulsion between two electrons, and this force is repulsive, not attractive. So it is not gravity, it is different from gravity, because gravity tend to attract two objects. Here it is repelling. So what do we conclude from that? That like charges repel each other. And there are some other cases where you have a force of attraction also between proton and electron. Yeah, so that was also experienced, and that was also of the same order, and so it was rather nomenclature was given. Let us say electrons are minus and protons are having positive charge, and these neutrons are having no charge. Right? Why neutrons are having no charge, that also we'll learn in some short video, but not now. So this is how we have proved that there is a strong electric force present, which is not because of the weight. I'm talking about a atomic level. So there is a strong force present between two electrons, or between two protons, or between electrons and protons. This strong force is called electric force, and the property because of which this strong force is there is called charge. Normally this strong force is not exerted because the number of protons and number of electrons are balanced in any you can say atoms, and that's why we have a you can say balanced structure. No external force, no strong force is exerted. But there are certain processes through which we can have a charging of the body. Now let's get to the point. So what do we know so far? We know so far that charge is the agency because of which charge creates electric force. Charge can be of two types, positive and negative. Protons are considered positive and electrons are considered negative. This is merely a convention. You can consider electron to be positive and proton to be negative also, but that could be in a different universe where you have started the whole physics study. Here, hundreds of, that means many years have the study has they have taken this convention, so we have to follow it. So electrons are negatively charged, protons are positively charged. We also know charges, like charges, that is same charges, repel, and unlike charges attract. That is what we have observed, and that is what we have accepted. There is nothing to challenge in it. We are also going to state at that time that charge has unit known as coulomb, and the symbol is C. Electron or one proton is shown by E, plus E or minus E, and the charge of one electron or one proton is 1.6 into 10 raised to minus 19 coulomb. So it's a very small value, and that's why we rather have a unit 1 coulomb, which is charge of 6.24 into 10 raised to 18 electrons, right? So that's the bigger unit, which is coulomb, right? So we know about electric charge. It is the property of the matter because of which there is a strong force of attraction between proton and electron, or strong force of repulsion between two protons and two electrons. It is, they are having two different types of charges, positive and negative. Protons are positive, electrons are considered to be negative. When a body loses electron, it is said to be positively charged. When it gains electron, it is said to be negatively charged. Like charges repel each other, unlike charges attract each other, and the unit is coulomb. So that is how the, you can say, the concept of charge goes. Now let's get to the next point. So everybody is not attracting, not all the objects are able to attract the other object. So that means there are certain special processes through which we have enabled those objects by rubbing that comb on the hair or by rubbing a glass rod on silk. There is a process through which they have acquired charge. So the charge can be acquired or charging can be done in three ways. First is by rubbing. We call it friction electricity. Then charging is by conduction. That is the second option. And third is by induction. So a body which is exerting force on the other body, whether it is attraction or repulsion, can be having any of these three situations, because of which it is now experiencing the force, right? So electric charge is allotted because of any of these. We'll start with the charge, you can say rubbing. So when you rub or when you apply friction, you are doing work on certain objects, and those objects are generally insulators. Now we know the insulators, you have learned in the previous class also. The matter which is not very good conductor of electricity or electrons, they are called insulators, or they are having very high resistivity. So these are the matters which can be charged by rubbing. You cannot charge conductors by rubbing. If you take a spoon and you are holding it and then you rub on a silk and then you try to get it near to the other objects, it is not going to exert any force, right? So conductors do not get charged in that fashion, but insulators do get. So what happens? So whenever you are rubbing, you are doing external work on it, because of which on this surface, what all you can say excess charges are there, they are transferred on the other body, right? So the work done by you when you are applying friction, when you are rubbing, you are actually doing work so that those charges are moving from one surface to the other surface. There are certain objects, there are certain matters which are having tendency to accept electrons and become negatively charged, and there are certain objects which are having tendency to lose electrons and become you can say positively charged. So they are listed in a triboelectric series. So we'll list it down in some other lecture, but here the you can say human hand, glass, you can say plastic, these are all objects which are having tendency to accept electrons and become negatively charged, and paper and other objects which they become rather relatively positively charged, right? So which objects are becoming positive and which objects are becoming negative charge, that depends on their atomic structure, and you must have learned some basics about it in your chemistry class also, and we are also going to learn it in part 2 in atoms and nucleus, right? So that is about you can say by rubbing. So we know that static electricity is there because of rubbing. Now second is charging by conduction. So suppose a charged body is there which is having say positive charge, and I bring to its contact an uncharged body, a sphere of which is made up of a conducting material, but it is uncharged. Then after some time you will see that this charge is both become positively charged, or these charges are distributed, right? So half charge is going to be, if suppose this was Q and this was 0, so here Q by 2 is over here and Q by 2 is over here. This is what happens when you have a conduction. you can have a wire joining them, then also the same thing is going to happen, right? So this is charge by conduction. It happens in the metals which are conductor, and we know the property of the matter which are having you can say tendency to allow the flow of electrons very easily are called conductors. They do so because they have free electrons, they do so because they have particular atomic structure, and that's why their property of conductivity is there, right? So we are going to learn in detail about that property in other chapter, but here we assume that we know about what are the conductors, and in that the charging takes place in this fashion, right? So if you the other you can say example is that suppose you are having a charged body, uh, then you would like to transfer that charge. There's famous example of earthing or grounding. See, when there is a lightning stroke on a building, then a heavy charge is you can say received through that lightning stroke. Now this heavy charge is going to create a dangerous situation, and if you want to avoid, what do you see? This is the building, and on the top of it we generally keep a you can say earthing arrangement, and it is grounded in the ground. So what all charge is received, it is grounded, and this is nothing but it's because of the property known as charging by conduction. So what all charge which is accumulated by this you can say receiver, it is you can say sent to the ground. Ground is generally assumed to be at zero potential, or it is at neutral. So all you can say charge will be absorbed by ground, and this building or the residents will be saved, right? So we exploit this situation, we exploit this property of you can say charging by conduction in this manner. All the equipments which we are handling, they are also having a earthing pin, and that is also the property is that whenever any leakage charges are there, they are conducted to earth through that earth wire, and that free charges, leakage charges should not travel through your body, otherwise human beings experience the phenomena known as electric shock. Okay, so now charging by induction. So charging by induction is that if you bring a charge object near to the other object is at present having, you can say, no charge. But the famous example which is given in the book is that consider that you have a uncharged object like this. So what all charge was there is equally distributed, and there was an equilibrium. And now you bring a, you can say, positively charged rod near to this. What is going to happen? As you have charge positive to it, it is going to repel the positive charge, and so positive charge is going to accumulate the other side of the you can say sphere, and at the same time the negative charge is going to be attracted over here because of this situation, right? And we have to assume over here that these are insulated. The stands are insulated, otherwise the charge can get grounded, right? Now the thing is that if I remove this you can say rod which is positively charged, then the whole distribution will get again neutralized and nothing is going to happen. But keeping this rod in the same position, suppose I, you can say, move away this two charges, two spheres rather, sorry, then it is going to continue in this fashion. and there is going to be force also experienced between these two spheres. At that time we have to assume that yeah, this glass rod which is positively charged is still very near to the first one. And now even if we remove this was first step, this is second step, and now even if we remove that glass rod which was positively charged, the thing is that in doing so, in step 1 or step 2, whatever charge was there on the glass rod is not given away to this sphere. The glass rod still remains, still maintains, still holds the same amount of charge, and this is induced charge. Right? Now suppose I will remove in the third step, I take away the agency, this glass rod which has caused it, then still the charge is going to be there on both the sphere, but now it will be equally distributed to the whole surface. Right? So now the spheres are also far away and the glass rod is taken away. So now what I have done, I have been able to assign charge, positive charge to this sphere and negative charge to this body, which was, they were initially neutral. So here the process through which I have imparted charge to these bodies is called charging by induction. So whenever charged body comes in near to the other body, which is of course it has to be a conductor, charge by induction can take place in conductors only. It cannot take place in the insulation, right? So in conductors, charge can move around. So positive, negative charge they get you can say redistributed because of this situation. And the process by which I have imparted the charge, positive charge on this object or the negative charge on this object is called charging by induction, right? So this is called the concept of charge. We have introduced through example of static electricity. We have seen what is electric force. We have seen the definition of electric charge. We have seen how we are going to, how these charges are assigned to those bodies. So three processes are defined: charging by conduction, charging by rubbing frictional electricity, charging by conduction, and charging by you can say induction. So that is what I intend to cover in this lecture. In our next lecture, we are going to discuss about properties of charge, and at the same time, we will also solve some examples related to the properties of electric charge. Right? So that's all. I hope you enjoy this video, and it's certainly going to clear your concepts.